Kirchhoff's second law. The Kirchhoff's second law is also known as Kirchhoff's loop law and Kirchhoff's voltage law. Okay, so let us study this with an example and then we will give the statement. So there are two names, that is loop law and the voltage law. What does this mean? It means that there has to be the involvement of voltage and there has to be the involvement of loop. So to study this, let us consider an electrical circuit. Here this is my electrical circuit A, B, C, D. Okay, and from in between A to B there is one cell. Let the EMF of cell be E1. Similarly, from B to C there is one resistance. Let us consider this as R1, and from A to C there is another resistance R2, and there is another resistance between A and D. Let us say this as R3. Yes, there is D and C, and in between them there is one cell, another. Let the cell be E2. Okay, EMF of cell is E2 and EMF of the cell is E1. So this is my complete electrical circuit. Now let us go to the Kirchhoff's law. Before going to the Kirchhoff's law, we have to remember this two sign convention which I will explain step by step, and please remember this sign convention depends upon author to author, but believe me, these two sign conventions are very easy and very important. Okay, so first of all it is saying loop. Okay, so let us make a loop. What is a loop? We know everything about the loop. So loop, let us consider one loop. Loop is like this. So this is my one loop. A, B, C, A is one loop. Similarly, let us consider another loop like this. And this loop is my A, C, D, B. Please remember, this part has got one loop. A, B, C, A, one loop, and this part has got another loop. A, C, D, A. There are two loops. Now, the direction of loop could be clockwise as well as anti-clockwise. It is depend upon you whether you take clockwise direction or anti-clockwise direction. You can choose it. For example, this is moving in this direction. It means that this is in clockwise direction. Similarly, this is also moving in this direction. So this is also in clockwise direction. But you can choose in any direction. If you choose this clockwise, you can choose this anti-clockwise. If you choose this clockwise, you can choose this anti-clockwise, no matter. Okay. So let us go to the statement now. Okay. So the Kirchhoff's law, second law statement states that sum of all potential drop and EMF in a closed loop is equal to 0. So this is the statement. Let us consider any loop, and if I consider the EMF, the potential drop, if I add them all, this will be equal to 0. Understood? So this is the statement. Now one more thing the students get confused is that I have only considered the resistance. No, it may be inductor, it could be a capacitor. If there is potential drop, then if you add all that potential drop, it should give me 0. For an example, if you add this, okay, if you add say 5 plus, okay, 7 plus, okay, again say 10 plus 7 plus 10 plus 5 is equal to 0. It should always give me 0. But what happens here is, if you see all are positive number and I am saying this is 0, it means that it is not possible, right? So this is very important concept. Then what should be there? there should be some quantity should be negative. Only then this will become positive. For an example, if I take this one and this is positive, cancels. If I take this one and if I take this one, then it will become 0. Plus 5, minus 7, plus 7, minus 10, and plus 10 will cancel and I get 0. It means that the potential drop and the EMF in closed loop, sum of the potential drop or sum of the EMF has to be negative, so that whenever I add them, it will give me 0. So this is very important concept. Okay, it is not actually written in the books. So this is one concept. I am saying it should be 0. When it becomes 0, it becomes 0 only when sum of equal amount, equal quantity is positive and equal quantity is negative. So there must be one and another positive and negative. So this is the example. So it is loop law. So let us consider a loop. So loop is my, okay. So let me rub this out and let me consider a loop. Okay. So look, which loop I will consider? I will consider A, then B, then C, then again A. So it makes a complete loop. So I have to add all the potential drop and all the EMF. Now, before going to the sum, there is one very important point where the students get confused and they will fail to understand. First of all, we have to assign the direction of current, okay, by our choice. So let us give the direction of current here. Now we also know that the direction of current is always from negative to positive. Understood? It flows from negative to positive. So if I see here, there are two EMF, two cells, so I will consider E1 first, and this is negative and this is positive. It means that the current will flow in this direction. So let this current is my I1. Okay? And let us see, is there any another EMF? Yes, there is another EMF and this is negative and this is positive. And we also see that this current should flow in this direction, and let this be I2. Why I2? Because current flow from negative to positive. Now how much current will come from here? I1, I1, I1. So here it will be reaching I1. Okay? And here it is going I2. Now there is a junction. It means that we have to solve, we have to assign the Kirchhoff's first law, and only then we can do the Kirchhoff's second law. So at this point, this is going and this is also coming. Then what does this mean? It means that this current will go in this direction. Okay, in this direction, and this current is my I3. For an example, I1 coming, I2 coming, and this I3. Now how much will be I3? It is all the currents coming at this junction should be equal to the sum of all the current going away from this junction. And how much current is going? This should be I1 plus I2. Okay, because I1 is coming, I2 is coming, here going is I3, and which should be equal to I1 plus I2. So this are the direction of current. Now from here, how much current it will go? Here, this will be my, again say I3, but I3 is equal to how much? I1 plus I2. Okay. Now, how much current will go here and how much current will go here? From this point, it will be again divided into two, coming, one part will go this side, another part will come side. And how much current is here? I1, then this will be my I1, same current. How much current is going in this direction? I2, so this should be my again I2. Understood? Okay, this is done. Now let us go to the loop A, B, C, A. A, B, C, A. Okay. Now from A to B, there is no resistance, that is, there is no potential drop, but there is an EMF. Okay. So let us go, let us write the value of EMF. So to do so, we have to consider the sign convention. So sign convention, let us see here. If we move from negative to positive, if we move from negative to positive, it means that this is negative and this is my positive. If we move from negative to positive in this direction, okay, this is negative and this is positive, of cell and this is shell, then the EMF of cell is taken as positive. If the EMF of the cell is say 2.5 volt, then it should be written as EMF is equal to plus 2.5 volt. Why? Because we are moving from negative to positive like this. So this is one example. Okay. So we are going from A to B. This is my A and this is my B. And we are moving from where to where? Negative to positive. Then the value of cell should be taken as positive. Then this will be how much? It will be my E1. Here I will write plus. Then the statement says that sum of all the potential drop and the EMF in closed loop is equal to 0. So sum means I have to add plus. So A and B dot. Now let me go to B to C. While going from B to C, there is one resistance and the resistance is R1 and there will be a potential drop. And we know that potential drop is equal to V, which is equal to IR. So how much is the potential drop? Formula V equal to IR is the potential drop or the voltage drop. Okay. So again I have to go to the another kind of sign convention, which is I have written here. See, if the direction of loop, please remember, and the direction of current is same. Okay, it means that if I go in this direction, okay, let us consider this is the part of loop and I am going like this. I am going, which is this B to C. I am going from B to C. Okay. If the direction of loop and the direction of current is same, then the value of current is taken as positive. Here from B to C, what is the direction of current? Direction of current is in this direction, and how much the current is? I1, and this is my R1. Now, if you see here, I am going from B to C and current is also going from B to C. It means that the direction of loop and the direction of current is same. Now, if the direction of loop and the direction of current is same, then the value of current is taken as positive. So, I will take this as how much is the potential drop? V equal to I into R, and how much is the current? I1, and how much is the resistance? R1. So, here I will take the positive. Okay, current is positive. After all, this will become positive in later time. Then I have to add sum of all the potential drop and the EMF in a closed loop is always equal to 0. Sum means addition. Now I will go from C to A. Whenever I go from C to A, I am going from C to A in this direction, and the direction of current is also in the same direction, isn't it? It is in the same direction. So direction of current and the direction of loop is same, the current is positive. So there will be a potential drop. How much is the potential drop? I into R is the potential drop. Okay, and I is positive. And how much is current? This is I3, which is equal to I1 plus I2. And how much is the resistance? Is my R2, and this will be equal to 0. Okay, so let me write it again. E1 plus I1 R1 plus I3 R2 is equal to, so this is my Kirchhoff's law. Now there is another loop. Which loop is this? This loop is A, C, D, A. Okay, so let us consider another loop. The loop is A, C, D, A. It should be a closed loop. I start from A and end at A. Now from A to C. Okay, I am going from A to C, but the current is going from C to A. Are they in the same? No, they are in opposite. For that, what will be the value of current? It should be, if it is same, it should be positive. If it is opposite, then it should be negative. For that, let us go to this. If the direction of loop, okay, direction of loop and the direction of current is opposite, it means that I am going in this direction. Okay, I have got here resistance. This is my A and this is my C, isn't it? I am going from A to C, and this is my R2. I am going in this direction, loop direction, and the current is coming in this direction, which is my I3, and this is R2. Now this says that if the direction of loop and the direction of current is opposite, okay, then the value of current is taken as negative. I am going from A to C and the current is coming from C to A. They are opposite, one going down, one going up, opposite. That time I have to take the value of current as negative. So there will be a potential drop. I know potential drop is I into R, and the direction of current is opposite to the direction of flow. So I have to put the negative sign here. And how much is the current? I3. And how much is the resistance here? R2 is the resistance. Now I have to add this. Sum of all the potential drop and the EMF in a closed loop is always equal to 0. Sum means addition. Now I go from A to C. Now I will go from C to D. Whenever I go from C to D here, so this is like this. Okay. So this is C and this is my D. This is negative, this is positive, and the direction of current is in this direction, that is I2. There is no resistance, so there is no potential drop, but there is EMF, which is E2. So for EMF, I will go here. If we move from positive, okay, to negative, okay, if we move from positive to negative, first we move from negative to positive. Now in next, if we move from positive to negative of cell, then the value of EMF, then the EMF of cell is taken as negative. If we go from positive to negative, then the value of EMF is negative. So if it is 3.0 volt, okay, then what is the direction of loop here? I am going from, okay, not the loop, it has to be the EMF, no problem. See, if we move from positive to negative of cell, if we move from positive to negative, let us not do this. If we move from positive to negative, that is in this direction, I am moving from positive to the negative, then the EMF of cell is taken as negative. At this time, then EMF is equal to minus of 3.0 volt. Okay, I am going from positive to negative. I am coming out from the negative, so it has to be negative. So in C to D, there will be a minus of E2. Understood? From going from positive to negative, EMF is negative. Going from negative to positive, EMF is positive. Again, I have to add, then I will go from D to A. Whenever I go from D to A, I am going in this direction, but the current is coming in this direction, that is they are opposite. That means the current has to be negative. And there will be a potential drop, that is I into R. And what is the value of I? Here is I2 coming in this direction. What is the value of resistance? Is R3, and I reach the point A. So this will be equal to 0. So let us arrange this. So I will write like this, okay? Minus I3 R2 plus minus minus E2 plus minus I2 R3 is equal to 0. And or this can be written as I3 R2 plus E2 plus I2 R3 equal to 0. Taking the common minus and moving it here. So this is the Kirchhoff's loop law and Kirchhoff's second law, which are very easy, and we have to remember all this sign convention. In the next lesson we do there are some numericals, very important numericals. Thank you.